Matter cannot be created or destroyed, as said by Anton Lavoisier.
In order to do stoichiometry, a balanced chemical equation is needed.
This is a real-life example of balancing. As you can see, this is a seesaw. On the left, we have Jim. Jim weighs 200 pounds. On the right side, we have Jack and Jim. And Jack weighs 100 pounds. And Jim also weighs 100 pounds. This seesaw is balanced because 200 equals 100 plus 100, or 200 equals 200.
As you can see, this is one of the easier examples of balancing chemical equations. On the left side, or the reactants, we have potassium chlorate. And on the right side, or the products, we have oxygen gas and potassium chloride. On the left side, as you can see, we have the 2 in front of the potassium chlorate due to the fact that the 2 distributes to each side, or each element rather. Now you're not supposed to have a 2K, a 2Cl, or a 2O3 because that's not how coefficients work. As I said, it distributes to each one, which makes this 2K, 2Cl, and 2O3, 2O2, and KCl. As you can see, on the reactant side, we have 2K and 2Cl. To balance it on the right side, we need to put a coefficient of 2 to distribute to one of those, which means it's 2K and 2Cl. As you can see, these are now balanced. Now we need to balance the oxygen. So the coefficient actually distributes to the 3 to make it O6. And on the left side, we need to add a 3 to multiply to the 2 to make it O6 as well. This means that we will now have a balanced chemical equation of 2 potassium chlorate equals 3 oxygen gas plus 2 potassium chloride.
So as you can see, unlike the last balancing chemical equations, this one has no coefficients written in. This is more difficult because, unlike the last one, the left and the right are both blank, meaning you can't use one of the numbers to find the other one. So, the way to start an equation like this is just to count the amount of elements that are on each side. So, for instance, on the left side, there are 7 carbons, there are 16 hydrogens, there are 2 oxygens. On the right side, there is 1 carbon, there is 2 hydrogens, and 3 oxygens. So we're going to start with carbon and balance that first. This is because there's only one location for carbon on each side. This means that the element carbon is only in one part of the equation on each side. One here and one right there. Since there are 7 on this side and 1 on this side, it means the coefficient for this is going to be 7 and this is going to be 1. Next, we move to hydrogen. There are 16 hydrogens on this side and 2 on this side. That means, since 16 divided by 2 is 8, we put an 8 here and a 1 here. So now we can count the elements' numbers with the new numbers. So on this side, there are now 7 carbons, and there are now 16 hydrogens, which means carbon and hydrogen are both balanced. Now we have to worry about oxygen. So 8 times the subscript of 1, which is imaginary, is now 8. 7 times 2 is 14. That equals 22. So how do you get 2 to balance 22? Well, 22 divided by 2 equals 11. And now there's a balanced equation.